Okay, I gave the kids some problems to do from yesterday, and here is the first one. If you have y equals 2x squared minus 3, is it odd, even, or neither? And you had to prove it. So if you just wanted to sketch it, you could go, okay, I think it's a parabola, but I'm not sure exactly where it's been moved. I know it's been moved down a little bit, and it's been stretched. Maybe that's going to make it not be even, but it turns out it is even, and here's how you can prove it. Just a sketch wouldn't prove it anyway. F of negative x comes next, and what's the last category? Negative f of x. Good. And if these two are equal, then the thing is what? Even. If these two are equal, the thing is odd. What if these two are equal? That doesn't mean anything if they're equal. Okay, if they're equal, we don't care because it's just the thing is either odd or it's even or anything else doesn't matter. It's just a neither. Okay, so this is nothing special. It's just if those two are equal, it's a neither, and so is any other situation. They don't have to be equal to be neither. And that's the thing I don't want people to think is, oh, well, these two weren't equal, so I didn't think it was neither. No, it's either even or it's odd, or any other situation means it's neither. All right, so this is 2x squared minus 3, and this is 2 empty spot squared minus 3. Drop in a negative x, and you simplify it down, and you get 2x squared minus 3. And since those are exactly the same thing as each other, then this is even. Okay, good. Just for kicks, I'm going to do the third one. And the reason is just to show you how you would do it. I'm going to drop the function in with parentheses. I hope you've noticed there's a lot of being careful with parentheses in this class. And then this becomes negative 2x squared plus 3. And that is not equal to that, but I don't even care because if it was, it wouldn't mean anything anyways. The only thing that's really pertinent is 2 of them are going to be equal. If all 3 of them are equal, you did something wrong. You will never have a situation where they're all 3 equal. Otherwise, the thing is called even and odd, and there's no such thing. That is this weird little function. I still haven't asked a colleague about that one yet. About why that would, it's just a constant 0. Why that? I think it's because it doesn't qualify as a function, but that doesn't seem right either. So, all right. Anyway, let's move on. The new stuff for today is about taking terrible functions like this and moving points that were on the original function, moving them around. I think it needs a little more intro, so let me show you this. Let's say I had a function needs to go up 3 and it needs to go right 5. Now I can write that out in words, but if I wanted to write it out as an equation, do you get that my new function is going to have a different name than f of x? If I have f of x to start with and I'm going to move it around, it's not going to be called f of x anymore. It's going to be called g of x. And g of x will be my old function, except here's how to show it math-wise, that it moved up 3 and right 5. Do you get, this is just trying to say, take your original function and move it right 5 and up 3, and you'll get your new function called g. That's what that means. Okay. So if I gave you one like this, p of x is going to be, take your old f of x function, times it by 2, move it 3 to the right, and down 7. So the question becomes, what if I had a point that was on my original function f of x? F of x, let's say it's some parabola or something, and it's over here, and it had this point on it. It had the point -1, 3 was on my original function. It's this green dot right there. Okay? If that was on my original function, and then I did this to my function, I made it really get stretched and moved and all kinds of changes. Where's that point now? Yes, you could think it through and go, okay, I have to move it to the right 3. That's not that hard. That changes my x. And then I have to move it, double its height, and then move it down 7 or subtract 7 from it. That gets hard to think through. Okay? I'm going to give you a simpler one and ask you this question, because some of the ones in your homework, a lot of them are actually really easy. What if g of x is just taking f of x and adding 2 to it? Which way did you just move your point? Up 2. So if the point that worked was 5 comma 2 and you moved it up 2, would that affect the x or the y? And therefore 5 comma 2 would turn into 5 comma 4. The new point that would be on the g function, if this was on f of x, this point would be on g of x. You with me so far? All I'm saying is the thing moved up 2, so I took this y and I made it go 2 bigger and I left the x alone. Okay? Now let's make it just a little more complicated. Let's say that the function isn't just f of x plus 2. Let's say it's 3f of x plus 2. Now I got to stretch it and move it. And the order matters. Do you get if I add 2 to something and then triple it, it makes a different answer than if I tripled it first and then added 2? Okay, so the order becomes really important. So I want to spend a couple minutes on order and making sure you get what order things have to be in. So everybody write this one out. F of x is equal to 3, 2x minus 1 plus 5. That is a normal parabola, a parent parabola that's been changed in a lot of ways. The order that you do it in is critical. And I'm going to teach you how to do it where you always start on the inside. And the first thing you would do then is you go to the inside. Do you remember this from last year in honors higher algebra or higher algebra, either one? Do you remember that you start on the inside? And do you remember you can't trust the stuff on the inside? I gave the example in my classes of I knew a guy that was in jail. And long story, but he was put in with a cellmate that had just killed somebody. And so now he was in with a murderer in his cell. And so don't trust anybody on the inside. Anyway, so don't trust this. What do you mean I don't trust it? Well, it goes in the opposite order of what you'd expect. And it does opposite things of what you'd expect. You would think this would make it twice as wide, because that's on the inside. And it's horizontal stuff on the inside. You'd think it would make it twice as wide because you get that times by 2, but it doesn't. It makes it half as wide. And you would think you would start by multiplying by 2 because that's the normal order of operations, but you don't. You do it in the opposite of the normal order of operations. Okay, so I have to do it in the opposite of normal. So if the 2 is normally first, that's going to be first. That's going to be second. And then we'll move to the outside. All right, so the first one is right 1. The second step here is that times by 2, which is a vertical stretch of 2, false. Horizontal shrink of not 2, 1/2. There you go. Then you move to the outside. And on the outside, we have to do it in normal order because you can trust things that are on the outside. They go in the normal order. So this times by 3 is supposed to be before the plus 3. And it is before it because we can trust the order. We do it like normal, like PEMDAS. Please excuse my dear Aunt Sally. And the parentheses and exponents are not here on the outside. All we have is multiply and add. So I go multiply first. So that is a vertical stretch factor 3. And then the last step would be the 5, which is, you can just say up 5. I know it's a horizontal move. I'm sorry, a vertical move, but you don't have to say that. That is the order you'd have to do it in. Now, would you agree if I change the order by throwing in some extra parentheses up there, then it would change the order you should do it in. Get what I'm saying? If I change something by adding parentheses, it'll change the order. So let's see if any of you can catch this. What if it's a very similar type of problem? There's 4 things that need to be done here. Y is the same as f of x. What do you think the 4 things in order should be now? And remember, I changed it because I put in parentheses. You better change it too. What's first? What's second? What's third? What's fourth? I know some of you are going to goober this. At least a third of you. So it's tricky. Be careful. Any hard math problem, you always start on the inside. So we're starting on the inside. Of those 2, there's only 2 things to choose from, the 2 and the -5. I know some of you are going to say, well, this is how you did it last time. But last time there weren't parentheses in there. So now that there's parentheses in there, wouldn't you agree that normally parentheses get to go first? But we're on the inside where we do it in the opposite of normal. So they don't get to go first. Now we got to do this first. So it's going to be horizontal shrink factor 1/2 was first. How many of you caught that? All right. Well, I thought so. A lot of people got that wrong. So you get that parentheses normally are first. Therefore, they can't be first. Because we're on the inside. All right. So that 2 had to be first. And then we go do the parentheses, which is right 5. Now we move to the outside where we have these 2 choices, and it's easyville because you know like opposite time. It's just what's normally first? Multiply? Yeah, so you do that first. So that is vertical stretch factor 3 and up 7. All right, I'm going to give you one more since very few people got that exactly right. See if you can catch this one. I'll use a different function. Absolute value. Tell me what order you think I should make the changes. All right. You should have started on the inside. And there's parentheses, so those would normally go first. So they don't go first. We go with horizontal shrink factor 1/2. Number 2 then is the right 10. Number 3 is on the outside, it's vertical stretch factor 3 and up 4. Raise your hand if you had that one right. Good, you're catching it now. So watch out for parentheses because they change the order. It's a real trap. Everybody naturally just wants to go in and do that stuff first. Don't, because that's what normally happens and you're on the inside. So you got to not do it normally. All right. So now we've taken a break from that other stuff for a moment. Let's get back to this yellow page right here. Now this is saying this point was on my parent function. This would have worked in this function, the f of x function. So the question is, if I'm making a new function called g, where it's done all these changes, you know, those 2, 3, 4 things, can I take that point and make all those changes to it? Yes, but it's a nightmare to try to do that in your head and go, okay, I got to first, let me think, horizontal shrink it by 1/6. Ugh. And then I have to move it to the right 4, and if you try to do this all in your head, it's a really hard process. So instead, we've got a system that'll work. It'll work every time, and it'll work on the really hard ones. And here's how it goes. Would you agree that this f here is just begging for an f of x, right? So you get that this is kind of where the x should be. So 14 is what we want the x to be. So we say 14 should be 6x minus 4. And you solve it. Go ahead, solve that. I'm going to add 4 to both sides. And notice this forces me to do it in the right order because I know how to solve equations. If you try to do it in the other one, you're going to screw up the order. Yes, I could have taken the 14 and made it 1/6 as big and then moved it 4 to the right, which you have to think about what's right and what's left on a graph, and whew, it gets complicated. But we could have gotten it. What's x have to equal? 14 changes to 3. My new point is 3 comma something. Could you have done that by taking the 14 and taking 1/6 of 14? And then how do you move it 4 to the right? You actually add 4 to it? We could have. All right. So, but I don't want to do it that way because it's much more complicated than this way I'm showing you. All right, so my new point, which I'll put down here, we've got the beginning of it. It's 3 comma something. Now let's get the y. Well, like the same process we used last time was we said this is where x should be because it's supposed to be f of x, right? That's what x is supposed to be. Well, where's y supposed to be? What is y equal to? I've said it a million times. F of x. So f of x, which is this whole thing, this is f of x. That should be 8. So I put an 8 right there. And now I have 14 minus 2 times 8, which is 14 minus 16, which makes negative 2. The 8 became negative 2. Here's how I could talk you through that one. The 8 became negative 2 because first we had to take the 8, and do you get my function is times it by negative 2 in front, which would do what to my point? It would take my 8 and make it twice as big, but the opposite way, which would be negative 16. Then this is like a plus 14, and negative 16 plus 14 is negative 2. You could have talked your way through that one, but you're likely to make mistakes in a couple areas, mostly about the order. So instead, learn to replace the y with whatever the f of is. That whole thing becomes 8. All right, let's see if you caught that. Go on to the next one. If you understood that process, you should be able to take 1 comma 2. Go ahead. Yeah, I know. Okay, let's see how you did on this one. We have taken this and set it equal to that. I hope you also, this is the harder part, can take the 2 and set this is f of x. That part becomes 2. And so you should have negative 8 times 2 plus 10. So that makes negative 16 plus 10, which makes negative 6. So the point would become 2 comma negative 6. That point becomes that point. Raise your hand if you got that one right. Okay, good. Then I think you get that part. All right, so let's actually look at your homework for today, which is right here. And we'll do the first couple together. They'll be super easy. Like got you through really hard ones. And so this is going to feel like, what's wrong? It's too easy. So the x, we are doing all of these, 1 through 8. The x of 2 goes with that, and you set that equal to that. So x equals 2, and that's it. Do you get, we didn't make any changes to the x? Think about it. The point 2 comma 3 has to move, but we only moved it up 3, so we're only going to change the y, so it actually makes sense. So this point should become the 2 equals x is the x part of it, so 2. And the y part is negative 3, which is right here. That goes in for all of f of x. That becomes negative 3. And negative 3 plus 3 is 0. Did you get 2 comma 0? All right, now I want you to just think through. I know that was a whole process and everything. Just think about it. The function got moved where? Where did the function move? Up 3. Doesn't it make sense then that this point, if you move it up 3, would become this point? All right, but I need you to know that process, because when they're super easy, you could just go, oh, I'm just going to move it up 3 or left 3. But you need to know the process. Again, try number 2 then with the process of stick the x, make an equation for the x. Miss T, what is the equation for the x? Nope. 2 equals x plus 3. And then you solve it. So we subtract 3 from both sides, and you get x equals negative 1. Raise your hand if you got x equals negative 1. Okay, good. This is where that process, this equals that, is the equation. Don't try to think these through as much as afterwards when you're done. The awesome thing would be that after you're done, make sure it makes sense. Okay, so we got negative 1 comma, and then where does the y go? Well, it goes where the f of x is. This is the f of x. That becomes negative 3, so y is negative 3. Now look back and see. Why did we only change the x? Because we were moving it to the left, so it don't make sense we would only change the x. Make sense to you? All right, try this next one, and I'll just tell you the answer, and you'll see if you get it right. Try number 4. No, you don't stick a 2 here. You're doing it wrong if you think you stick a 2 there. You set up an equation for it. Did you get 3 comma negative 3? All right, good. Because you should have said 2 is equal to this, x minus 1. And then you solve it by adding 1, x equals 3. And then this part is f of x, so it's negative 3. And y is negative 3. So 3 comma negative 3 is your new point. Okay, good enough on those. You can finish up through 8 there. This page I felt was just too easy, because you just take the parent function, and what would you do if you had that one? Move it down 1. Where would you move it for that one? And where would you move it for this one? Left 3 and down 2, and that's all you'd have to do, and it'd be really, really, really easy. Okay, so I don't think we need to practice that. So skipping that page. Oh, what was there a mistake in that? It was left 3 and down 2. Okay, all right, on to this one. This page we are doing, and we have, who's this guy's name again from Simpsons? What is it? Sideshow Bob. There we go. Got some Sideshow Bob pictures on here. And I think he's stepping on a rake. And it's just that this is an inverse of this one. It's like a reflection. That's all that. That's why that's up there. Anyway, so this goes with this problem. This one is supposed to be graphed there, and this one's supposed to be graphed up there. There's just 3 graphs. They're in funny places, but so what are we supposed to do? We're supposed to take the original graph and move it, what does that mean? Down 2. So you take each point and take each point and move them down 2. Now we can do the really complicated process of what is this point exactly? It's -2 comma 0, and go through that whole set up the equation thing. But I think it's, in this case, so easy. You just should take each point and move them down 2. So I'm going to take that point, which was here, and I move it down 2. So you almost might want to graph the original on here. There's the original points. And then you got the ability with your iPad to like circle it and drag the whole thing, don't you? That'd be a pretty good way to do it, wouldn't it? Okay. This one will be a little more complicated than dragging it somewhere. You'll have to figure out how to do that one. But if you realize that the f of x is like your y, you're doing something to all the y's, I think you can handle it. Okay. So that page is also assigned. And this is the same exact thing, except it doesn't give you places to graph them. So I'm not going to assign them. Instead, I'm going to ask you to do the other thing. I want you to translate 2 points for each. Here's the 2 points I want to give you. 1 comma 5 and 3 comma 7. We'll have an odd theme. 1 comma 5 and 3 comma 7. I want you to translate those 2 points. You know what? That's going to be too complicated. Just make it 1 comma 5. Just take 1 comma 5 and tell me what the new point would be for all of these. So this gets a new point, this gets a new point, and this gets a new point. And I strongly recommend you use the system, because the ones we do on the test will not be the easy kind, like where you can just go, oh, move it to the right one. We will have like 5 things going on. You'll need the system, where you set the x equal to whatever's in there, and the y is this whole thing. Okay, so there's your homework. Again, we are adjusting this. You are not graphing it. You are moving the point, finding a new point for 1 comma 5. Yes? Yep. It tells me that whatever this original point was, it got moved to here. So like if this original point had been that one right there, that point under this transformation, I can tell by just looking at it, it's going to move down 1, so it would move it down 1. So it's like I had a point on my original. When I re-graph it with this new change, where does it go to? Just trying to figure out where that point moves to. All right, that's all I've got for you for today. I do have one more problem on the board over there for review that I think it's worth doing. I'm going to put it up here. You guys already have the answers for it, right? Because we did it earlier in the hour. So I'm going to write that up here with a pause. Okay, so here's the question I asked at the beginning of the hour. I gave him this picture. Oh, and there's an arrow on the end of this. That's important. And I said, find for me the local minimum, local maximum, absolute min, absolute max, where it's increasing and decreasing, and where is the function less than 0. So I'm going to answer those questions real quick. Give myself a little bit more room here. And here's what you should have said. The local min is, oh, and I didn't label that either. Hold on. That spot right there is supposed to be -3 comma -2, because that is the local min. -3 comma -2. The local max is the 6 comma 9, and a lot of people think that this is a local max also. It is not, because you have to have points on both sides of it that are lower. In other words, it would have to make a turn like that, and then it could be a local max. That is not a local max. Okay, absolute min is the lowest it ever goes. None. Don't say negative infinity either. It's not where is it headed towards. It's what is the lowest. And there is no lowest. None is the right answer. Absolute max, there is a absolute highest. This does not have an arrow on the end of it, so that means the highest spot it ever was right there, which is 6 comma 9. Increasing. This is supposed to be over an interval. It's increasing from here to here. In that zone there, in the green zone, it was increasing. So we say the x values of those spots. So it's from -3 to 6. Decreasing, there's actually two places it was decreasing. From here to here. Oh, I'm wrong. To there. That would be from -7 to -3. Union with another place it was decreasing, which is from 6 to infinity. Not negative infinity. These are x values. That's y goes towards negative infinity, but x, these are x values, goes to infinity. And the last thing is, where was the function less than 0? Right here is where it was less than 0. And that was between -5 and -1. Be polite and stay quiet. And it was also decreasing between 10 and infinity. That's all I got for you for today.